All right, guys. Green on the left, notes on the right. Green on the left, notes on the right. All right, we do have only one vocab word. All right, here it is. Indirect measurement. Everyone?
Indirect measurements.
All right, so by the way, just kind of breaking this down to help you kind of remember this as well. What does the prefix in mean? Not, yeah, so this is basically not direct measurement. So basically it's not like you're going to be taking a ruler and measuring something. Okay, this is called indirect. All right, so here's what indirect measurement is. Using the properties of similar triangles to find the measurements that are difficult to measure directly. All right. So, guys, here is about indirect measurement. Okay, that's a good description of it, but here's the bottom line of what this lesson's about. Similar figures. Indirect measurement creates two shapes that are similar. All right, I'll show you what that means. It's kind of like real life problems with real things outside, for example, or that create similar figures. So you're going to see a lot of the same skills that we did during our similar figure lesson. Okay, so have your book, page 240. Page 240. Okay. $240. Problem 3. All right, take a look. On number 3, let's go ahead and close read that. It says, a flagpole is 30 feet and is 3.5 feet high. The mailbox casts a shadow that is 5 25/100 feet long. How long is the flagpole shadow at the same time? Okay, so some of you guys might have you're looking at it and go, wait, what? Okay, well let me describe how this is going to create similar figures. All right, here we go. Step one is this. I'm going to draw a diagram. I'm going to draw a diagram of both of these figures. So here we go. The very first thing is a flagpole. There's my flagpole. Awesome, right? Okay, listen, it is a diagram. It is a sketching. Don't spend a lot of time on it. Just take a couple seconds. There's my flagpole. Here's my mailbox. There it is. Okay? Step 2, label it. So it says the flagpole is 30 feet high. So here we go. This side right here, from there down to there, is 30 feet. The mailbox, from there to there, it says is 3.5 or 3 5/10 feet high. The mailbox casts a shadow that is 5 25/100 feet long. Here we go. Shadow. 5.25 feet. It's a little longer than the height of the mailbox. Here's my shadow right there. Ooh, that's ugly. Sorry. 5.25 feet. How long is the flagpole shadow at the same time? Ladies and gentlemen, there's the flagpole shadow. That's our x. Now listen. the reason why I gave that little extra piece at the same time, because what's a shadow coming from, guys? The sun. It's the item and the blockage of sunlight in a specific area on the ground, right? That's what a shadow is. So basically, because they're nearby each other, that sun is, for the most part, they're in the same spot, it's going to have a shadow. Okay, all of these, by the way, are all going to be proportional. So no matter the situation that you're figured, they're proportional to each other. They're creating similar figures. If you want, right, you can, if it makes you feel better, you can close this up with a hypotenuse and make it like a little triangle. That's up to you. You don't have to. Okay? So here's what we do. Step 3. Go ahead and put the word proportions, and in parentheses, don't forget, pay close attention to corresponding sides. That's very important. So we're going to set up proportion. Here we go. I can go x, which is the shadow, over the height of the pole, which is 30 feet. So it's almost like having the base over the height. And for math purposes, I don't need to put my units yet. Equals, and remember it's the base over the height. So the mailbox is base of 5.25 over the height, which is 3.5. Step 4, solve. Well, unfortunately, right, this isn't one of those easy ones. We have to use cross products. Bless you. So 30 times 5 and 25 hundredths is going to be equal to 3 and 5 tenths times x. So 3 and 5 tenths x is equal to 30 times 5 and 25 hundredths. So we have 157 and 5 tenths. And then we divide both sides to isolate the variable, right? Do the opposite. We divide both sides by 3.5 or 3.5, 3 and 5 tenths. So we end up with x equals, so 157 and 5 tenths divided by 3 and 5 tenths equals 45. And ladies and gentlemen, step 5. What do you think it is? Yeah, put your units on, right? It's all in feet, so 4.5 feet is the shadow coming from the flagpole. That's not right. What happened? No, sorry, not 4. Sorry, it's 45. It's like, wait, that's not longer than 30 feet. My fault. That's why it's always good in your mind to take a look at, make sure it makes sense, right? It's reasonable, a reasonable answer. So 45 feet. Here's my pin that made that little dark spot. 45 feet. Okay, questions? Okay, listen. I'm actually, because this is very much like the problems we just did, we were working on for a while, let's move on to number 11. Let's do number 11 together, and then I'll have you guys try one after we do number 11. Okay, number 11 is just like this with a little bit of a twist. All right, so here we go. Let's close read this. It says, during a game, Josh, Devin, and Marco are in the following positions. Josh is 16 feet from Devin, and Devin is 5 1/3 feet from Marco. If Marco is 4 feet from both A and B, how wide is the key? Okay, now there's a lot going on there, right? So, first of all, you have it there. You don't need to draw it. I'm just going to draw it up here for your benefit. So we have the key on the basketball court, free throw line. Okay, and then we have positions of, right here, Devin. We have a position of Josh hanging out, and the key is Marco. I'm going to draw a little line over here for Marco. And then they have points A and B. So It's just points where the key hits the baseline, and then we have, it says that this from here to here, they say is D feet. Okay? I don't think I'm forgetting anything. So here we go. Actually, I am. They have a dotted line here, right? Boom, like that. And sorry, this is a little off, but I'll make it work. There, there, and that's it. So if I go ahead and do this, here we go. We'll go ahead and say on this particular case, step 1, okay? Considering the situation, you probably more than likely want to draw the figure, and that I'm thinking about it. On this particular problem, don't worry about it since I've already done it for us. Make sure, though, you write down the steps, okay? Step 1 is you are going to want to draw the diagram. The reason is because of step 2, which, of course, is we're going to label it. So when I go to label it, I'm going to reread my problem here. Josh is 16 feet from Devin. So Josh is 16 feet. So from this spot to that spot is 16 feet. Devin is 5 1/3 feet from Marco. Devin, right here, this is 5 1/3 feet right there. Probably should have used different color where it just shows up a little bit. This is 16 feet. This is 5 1/3 feet. This line right here. If Marco is 4 feet from both A and B, this is 4 feet, and so is this. How wide is the key? What they're asking, of course, is for D. Okay? Now, the reason why I said that this is a little more challenging because look, what you don't realize is this triangle, this upside down triangle, is similar to this triangle here. They're similar. One is a little bit bigger and flipped upside down. Okay? So, here's what this means. We need to know what this is. Now, if it makes you feel better, I'll just label this X right there. Or, you know, if it makes you feel better, you could put it D, because that's what they call it. Maybe we should call it D where I don't confuse you guys. Okay? Now, here we go. Step 3. Proportion. All right, remember corresponding sides. If you notice, I'm doing the exact same steps that we just did. So proportion, corresponding sides. So here's what I'm going to do. I'm going to take this and the base to this triangle, the long side. I tell you what, let's start with this because you guys are used to it. The base here that we're trying to find out is D. I'm going to take D and put it over one of the shorter sides, which is 4. I'm going to make that proportional to, D is the base of this triangle, the long side, right? So the base of this triangle, the corresponding side is this one up here. That is 16. Over 5 1/3. Base over one of the sides. Base over one of the sides. Now, step 4, right, is to solve. So here we go. We have something you guys love seeing, right? We have 5 1/3 times D is equal to 16 times 4. So we have 5 1/3 D is equal to 64. We're going to isolate the variable, right? So because it's multiplied with 5 1/3, we can divide by 5 1/3 here and divide this side by 5 1/3. So what we have, D, or the size of the key, is whatever 64 divided by 5 1. It's a complex fraction, right? So go over to the side here. 64 over 1. Remember, I'm making it in A over B form. Divided by, instead of 5 1/3, it's 15 plus 1. So divided by 16 over 3. When I go to solve it, KFC, where I can multiply it straight across, right? I'm going to flip-flop the second. Look at this. 64 and 16 can reduce by 16. 16 divided by 16 is 1. 64 divided by 16 is 4. Now I multiply straight across. 4 times 3 is 12. 1 times 1 is 1. And ladies and gentlemen, 12 along with step 5, right? It's all in feet, so 12 feet. I did exactly the same as here. It's just that the similar figures are flip-flopped, right? And they have a fraction involved. So we had to do a little bit of division of fractions, which something you guys should know how to do. All right? And everything else is the same. All the steps are exactly the same. It's just a little bit of a harder version of number 3. Okay, questions?
You have solved it by like converting 5 1/3 to 5 1/3 and then dividing to 64.
Okay, so listen, many of us want to convert to a decimal, okay? But be extremely careful, because if you convert to a decimal, that's a repeating decimal. At some point, okay, you'll probably want to round it. As soon as you round it, you are altering what 5 1/3 is, as soon as you round it. And therefore, your answer may not be accurate, okay? So I would definitely stick. This is how most of the time you're going to get accurate measures, by keeping it as a fraction, okay? Because remember, anytime you round, it's going to alter your answer, okay? And so you want to try to stay away from rounding as much as possible, all right? I'm glad you asked that question, because I'm sure a lot of people are thinking the same thing. Okay, here's what I want you guys to do. Try out problem number 6. Number 6, go. How many of you still need more time? Okay. Give you guys about 1 more minute. Those of you that finished early, just continue on your homework. Okay, guys, 30 seconds. Turn to your neighbor and share. Go.
I got 30 miles.
Okay, so now it's kind of funny, right? Because on this one, actually, they were already labeled for you. So realistically, you could have drawn it. You actually probably could have gotten away without drawing it, right? Because it's just similar figures on this one. So everything was already labeled. Here's what it says. It says the triangles below are similar. So it tells you. You don't have to figure out like number 11, right? They are similar. It says how far is it from Athens to Yukon? So here's Athens. Okay. Here's Yukon. So they also tell us from here to here is 14, and from this point to this point is 16. They're all in miles. Okay. So bottom line is if I take a look at this, it's almost like the one we just did, right? It's two triangles, a smaller and a bigger, obviously an enlargement because they're similar, okay? And they're just flip-flop, so this is like my base. This would be considered like my hypotenuse. This right here is my base. This is the hypotenuse. So here we go. This is what they're asking us for. How far is it from Athens to Yukon? So here we go. My hypotenuse over my base, so x over 35 is proportional to my hypotenuse, which in this case is 16, okay, over my base, which is 14. Here we go. Cross products, right? So we have 35 times 16 is equal to 14 times x. So 35 times 16 equals 560 equals 14x. If we divide both sides by 14, we get x is equal to, and then 560 divided by 14 equals 40. And of course it's all in miles, so I put my units of miles, 40 miles. All right. I'm glad to hear the yay. Good job, guys. I hope that you guys did well. All right, so indirect figures, guys.